Welcome to this new chapter in our tutorial series on additive manufacturing path planning with ElementX. In this video, we'll explore the core features of ElementX's additive manufacturing tools and delve into various practical use cases. Let's begin by generating a 3-axis path plan that adheres to the geometry of this ASME flange. To start, we'll open the Additive Toolpath window. This window is organized into 5 subsections, with the first being the general settings. The top portion of this section allows you to load the model to be sliced and choose the slicing mode. For this example, we'll select planar slicing to proceed with the path generation. The second section of the Additive Toolpath window is dedicated to selecting the post-processor that will tailor the generated path to the specific machine you're using. Here, you can choose Python to create a G-code path suited for CNC machines, or RoboDK to generate a multi-axis robotic path for advanced robotic systems. The final section focuses on the basic geometric bead parameters. These parameters ensure that the toolpath accurately reflects the desired bead geometry for the additive manufacturing process. The second window, called Bead Settings, contains parameters that define the details of the infill pattern, overlap, overfill, and underfill coefficients, as well as the offset percentage from the first contour. The overfill or underfill coefficient is particularly important and ranges between 0 and 1. A value closer to 1 minimizes overfill but may result in significant underfill, whereas a value closer to 0 reduces underfill but is more prone to overfill. Adjusting these parameters ensures precise control over material deposition and path accuracy. The next section is the toolpath settings, which includes a variety of parameters that influence how the material is deposited and, consequently, the energy deposition. Adjusting these parameters allows you to control the energy density and temperature profile along the path. By fine-tuning these settings, you can optimize the material deposition process for specific applications, ensuring the desired thermal and mechanical properties are achieved. The final section is the axis settings, which provides the operator with the ability to slice the part along a specific axis and/or adjust the tool's orientation. This feature is particularly useful for reducing the amount of support material required when printing parts with significant overhangs. By optimizing the slicing axis and tool orientation, you can improve efficiency and material usage while maintaining the structural integrity of the printed part. To generate the path, simply press Run. This action will create a color-coded path for visualization and execution. Each color represents a specific aspect of the toolpath. Pink indicates the infill, green links the infill paths, red defines the contours, yellow links the contours, and blue connects the different sections of the path. The blue connections are used to transition between contours and infills, or between layers, ensuring a continuous and efficient material deposition process. In the remainder of this video, we'll experiment with various parameters to showcase how they influence the generated paths. By adjusting these settings, we'll create different toolpaths tailored to meet specific operator requirements.
Never you.